Hi, my name is Trent from the University of Leicester, and today I'm talking about my new study assessing moisture recycling in satellite reanalysis and climate model datasets. Firstly, I would just like to acknowledge the East Living Planet Fellowship Scheme for funding my part of this work, and this study forms a broader part of my fellowship, water cycle changes characterized from atmospheric moisture recycling. So, motivation. Water vapor, as we know, is a key component in the Earth system, and with a mean residence time between the evaporation and precipitation of the atmosphere of around about 10 days. So, under Clausius-Clapeyron, we expect concentrations in the atmosphere to roughly increase around about 6% per Kelvin per decade. However, for precipitation, this is more complex due to control from atmospheric circulation and cloud microphysics. So while being highly correlated with extremes, precipitation has no simple correlation to temperature in the same way that water vapor does. Therefore, understanding the links between this residence time of water vapor in relationship to global precipitation has great importance for climate studies. So this study aims to really investigate these observed and modeled changes in water vapor precipitation. And this will be done by looking at something known as the recycling rate, which is essentially the difference between the varied percentage in precipitation and total column water vapor. And this recycling rate is also linked to hydrological intensities. This is why it's quite a nice way to do this. And for this, we will use an ensemble of both observations and models. So the idea is to look at the spread between both, get an idea of what's really going on. And some earlier looks using an ensemble of water vapor with one precip dataset show we do see differences between observations and the CMIP dataset as well. So in light of this, there will be a significant focus on the performance and quality of the observed datasets as well as their trends. So this table here just provides a quick overview of the datasets that are currently in the pool that I'm looking at. And these include total column water vapor, precipitation, and surface temperatures such as SST or surface air temperature. As new datasets come online or come available, such as the ESA CCR water vapor or land surface temperature products, these will in turn then be added to this pool and used in the evaluation. So here are some initial results of total column water vapor trends that we've already started to look at. And what we can see here in this table is on the left-hand side where we have the observation ensemble, on the right-hand side we have the CMIP ensemble, is that the difference over land and ocean, we see very, very sort of different patterns or behaviors, especially in the observations where we see quite a large variety of trends reported. And the other things we can notice here is that for observations, we see a stronger trend over ocean, whereas in the models, we see a stronger trend over land. However, this is not the end of the story. And these observations really need to be looked at in detail for things such as breakpoints, which are a key contributor towards stability and overall trends observed. And in that sense, we also want to look at this change relative to changes in temperature. And what we can see here on the right is a figure that looks at the correlation between temperature data sets and total column water vapor data sets. And again, here over ocean, we can see correlations which span quite a broad range relative to those over the land. And then using this information, we can then begin to really add context to what we begin to see in recycling rates and draw conclusions from this. And for those interested, here are the references used in this poster presentation. And thank you for listening.